Well, thanks very much, and thanks for your time. And it's a topic I am super passionate about. So at 20 minutes, I'm going to hit some of the high points, but I'd love to be able to catch you offline if you have any interest in any of the areas that I touch on here. But let's jump in. I mean, one of the things I want to say is, as you heard from Stephanie, I've got 40 plus years in the industry, and I have never seen a time of such disruption. And think about it. I started in the PC era. PCs had just came out. Then they became connected. Then it became a mobile device. You had the equivalent of a PC and a connection to the internet in your pocket everywhere you went. All tremendous change and disruption. But AI is more than that because it affects everything. It affects the very way that we've engineered how we run our life at home or our processes at work. And so it now becomes a fundamental question. I run our Innovation and Tech Committee, which is how we convey to our board at AMD what we're doing with technology and our roadmap, how we're deploying technology. And I sit on the board of Penguin Solutions. And so I can tell you from firsthand experience that this is existential for any company. This is material for any company. This is what boards, if they're a good board, they're becoming steeped and they're asking these very questions. It's an imperative. And when you think about what the dialogue is, you think it's all about productivity, and it started there. The questions were first, how do we stay productive? Are we going to get left behind? And what processes can we bring more productivity to? And as you can imagine, in the board conversation, it was, can we be more efficient? Jason talked about certain companies are letting staff go, and they're leaning in on that productivity of AI. My own view is, as you look at AI, and it's a discussion that I have in the boards that I'm involved with, it's really rethinking, bringing AI into the strategy of whatever it is that you are focused technology on. How is it indeed making your engineers more productive? Because it does, and it must. So how does that come into your strategy? Are you hiring the right skills? Are you educating the right materials? We've talked on a lot of that in the presentations here today. And so what I really think that these board discussions lead to, and what I'd urge each of you to think about is, how is AI giving you scale? How can AI allow you in your life, in your work, to do more than you ever dreamed? Because if you're not going to leverage AI to do more than you dreamed, you will be left behind. So the other thing that I will tell you, like what we're seeing, both at AMD, and we work very, very closely, across the industry, is that the AI innovation itself is just moving so quickly, faster than any innovations I've seen in the years I've had in the industry. And so, people do forget. The last panel in robotics, someone just mentioned that ChatGPT came out in the public version in fall of 2022. It's just hard to believe what's happened in the last 3 years. It was something we looked at and we said, well, it's all about these huge large language models like ChatGPT and the like, and then how can we get access to information? And frankly, it changed the human-computer interface because it became a dialogue that you're having to get access to a treasure trove of information. Lots of implications. Again, other talks here today have covered quite a bit on that. But the point I want to leave you with is where AI is involved to the last several years, and someone earlier called it agentic AI a buzzword. Well, sure, it's a buzzword, but do not underestimate where the evolution of models that can now be deployed in agentic processes. I translate it to a very simple way. What is agentic AI to me? It means that when people used to ask me even a year and a half ago limitations of AI and how can AI play versus your role as experts in the industry. And I would say, well, the problem is, like when I try and solve a big problem, what do? I get experts together. I can't do it with any one discipline. I've got to get a bunch of experts together, and it's just a multifaceted task to solve any problem. Well, that's what agentic AI does, because you are tapping on different models, different processes into other APIs that can run a myriad of tasks, and they're running in parallel with massive computation behind them. It's a complete game changer, and as much as we've evolved in the last 3 years, the pace is unending. So AI innovation is accelerating. It's also accelerating the path to invention. So we work with the national labs. The top #1 and #2 supercomputers are built on AMD CPUs and GPUs. The Lawrence Livermore system and the Oak Ridge National Lab. And what these labs and others worldwide are doing is they're transforming that kind of high-performance computing that they've always built up as key for national security into what's called AI for science. And so it's using the kind of technology used for weather forecasting and molecular modeling, but now they're able to accelerate the time to discovery. AI for science is mixing that traditional supercomputing with AI approximations for portions of the problem, and it's going to absolutely speed the time to invention. So it's just a phenomenal disruption going on. Now, you saw sustainability in the title. We talked about it a little bit here today, but there's frankly a challenge with this. And that is, as you look at how we've gotten those large language models to be so accurate, and yes, we're running it in different ways, and we have a mixture of experts, we're putting different models together, we're doing finely tuned models that we bring into the mix with our own data. But what it means is that the computation has moved to certainly a lot of computation in a bespoke number of hyperscale massive data centers. Now, what you're seeing is now with the reasoning that's going on, the research that you can run on these LLMs, and then, of course, the end inference applications. It's going to spread like wildfire across every enterprise business, home, education, medicine, any field you pick. What it says is that the power demands to manage running all of these models is on an absolute hyper exponential. And so we have to think differently about how we're deploying AI and about how we're deploying energy. It was great to see the CEO of Phillips 66 and to see energy into a couple of the topics here with KPMG. And really what this means is that you have to think about where do you need to run your AI. You have to right size how you're running AI, and it needs to be very thoughtful. And what that means is, of course, the huge LLMs. You're running ChatGPT, you're running Perplexity, you're running Grok. Those are going to be on massive compute installations that you're running. But for your application, when you fine-tune it where you're not asking any question in the world, but most AI applications are going to be fairly tailored. And so there you need to think, what is the task? I'm running an edge application. I'm on a factory floor. You can drastically shrink the footprint that you need. The power that you need is coming way down. And that goes right into the endpoints on the device that's sitting on your lap, on the device that's in your pocket. And so you're seeing the advent of small language models. You're seeing us being able to shrink the demands of how you can run the computation to right size it for the problem you have at a particular moment, a particular time in the process that you're running. And then, I just have to give an example of what goes behind that computation. So I could show you on the AI PCs and what it takes to design in this kind of a compute capability. And why does it take so much power? But I decided to show you on our GPU that we developed. We launched this in December 2023 to take NVIDIA head-on GPUs for the data center. And we're already on our 3rd generation. But what goes behind that? It's 153 billion transistors designed by thousands of engineers running over 500 watts. And that's from a product that we announced in fall of 2023. So the power now is approaching a kilowatt and more for one GPU. Excuse me, it's just, mind-boggling. I couldn't imagine the kind of energy demand. But we're already, just to keep it at that hundreds of watts, have tremendous innovation. We're connecting chips to chips over silicon. We're 3D stacking chips. This technology didn't exist just 7 years ago, 7 years ago. It's all new and driven by this insatiable demand for computing that AI drives. And you have different modes of computing. I talked about what do the hyperscalers need like Rock versus what does the national labs need that run an AI for science. It turns out they need a different combination of chips. And so again, it spurs innovation. We leverage the 3D chip technology we have to tailor it and have it be all GPUs in that huge complex for the likes of the hyperscalers or for the national labs or any other HPC installation to integrate CPUs and GPUs on a single carrier. But a point that the other second point I wanted to emphasize is open systems. We're committed to open systems at AMD, and I urge all of you to be committed to open systems. Open systems bring choice. I talked about bringing the right solution to the problem you're solving. You want maximum choice into what solution that you're bringing and how you go about implementing it. And I often give an example to the chip industry that I live in. We operate on open standards. I couldn't get that 153 billion transistor chip out that I just showed you without a cooperation across a whole ecosystem and a set of open standards that allows us to design our chip, but we share the same manufacturing facility as NVIDIA, our competitor on GPUs. How could you do that without open standards? And we do the same thing with our software stack. Our ROCm, our AI enablement software stack, our OCM, are completely open. Our platforms are part of open compute, and of course, Hugging Face and other open model repositories we're very, very supportive on. So, what I would urge you to do is to think about what you're doing and are you getting the right choice that you need to tailor your solutions? Often it comes up as you go about attacking these problems. One of the things that I know I get asked about quite a bit is if we're going to have choice, and we talked, you heard in Jason's comment earlier that we have really decoupled. It's not a debate, it's a fact. And so one of the things that everyone must do in terms of not driving choice is to have a resilient supply chain. You have to think about what's going on in the world. And we and our peers in the semiconductor industry, some of you don't have much visibility to what we're doing, but we are absolutely driving supply diversity across foundry. We already have chips rolling out of Arizona with TSMC, but also the whole back end. How do you package those complex 3D chips? I just showed you an example. How do you bring all of that together? How do you build it into the big rack computers? So diversity of supply is a focus of all of us in the industry. But the thing that I leave you with is think about this transformation we're in across multiple facets. I talked to you, I'll bridge back now to that boardroom discussion that's going on in whatever company you may work at. And what I'll tell you is it really is reinventing how you think about things. When you look at the AI native companies, what does it mean to be an AI native company? It means that they invented the company on AI. Their whole premise of their company is built on how am I deploying AI, how am I delivering AI services from the outset. You know what's really hard? Is for you, if you have existing processes, to come at it with that lens. It's almost impossible because we're human, and by our very nature, we're incrementalists. And so I really urge you to think about how can you transform your products and the processes that create those products, it starts with people. Are you putting the premise on the table of how we think differently? Are we thinking differently of how we're educating our workforce? Are we the students coming into our workforce? It's amazing what happens when you do so. We worked with ABSCI in drug discovery and have seen them cut in half the time for them to get new enzymes to market, literally cut in half. And I've gotten to know the CEO well. He said the hardest part, reinventing how they thought about the whole processes, how they go about it. Weather forecasting, that's that AI for science example I gave you. Weather forecasting has been around a long time. But what the several innovative teams created a mix of AI with the traditional deep computation, and they used it in hurricane prediction. And so they're still doing that deep and highly accurate, high precision math, but they're using AI to very rapidly analyze the data that when it comes in and get much quicker warnings out in terms of where that hurricane may land. And then safety technology goes without saying. You're seeing it every day where there's new security systems and in identification, AI being used for identification to provide safety and security. So end to end, I won't spend any time on this other than say it's going to be a challenge to think about how you right-size your AI applications. We work closely with Microsoft, for instance, because Windows is what runs on our PCs. So think about, as everyone talked about, cloud to the end device. Jason gave an example of Grok. He runs it on the cloud and it's running in his car. Those are non-trivial challenges of right-sizing your application and figuring out, what you need to run locally. It needs latency, or it's your private data you're just not going to let go to the cloud. And where do you need the heavy lifting to the cloud? So it turns out there's a lot of progress on that. Ourselves and our competitors are enabling our portfolio. Our entire portfolio is enabled to accelerate AI, but we have to figure out how we want to run those AI processes, where we run it, and how do we ensure it has the right security. So I've got just a minute left. And so, what I guess I'd leave you with is, one, there's a set of challenges that we talked about here today in terms of all the socioeconomic impact of AI. But if nothing else, I'll leave you with a couple of considerations. It's going to drive tremendous power and rethinking about power and how we deploy AI to be able to actually meet those lofty expectations of what we want to do with this technology. And it will really take the human element to redefine how you go about your objectives, your problem solving, your productivity gains that you want. I had fun sitting on a panel with Andrew Ng from Stanford just a few weeks ago. And I love it when he answered a question about what happens to the workforce. He said, look, for your people, he used engineering as an example. If you're a technology company, you have a set of engineers. If they're embracing AI, they're going to be, each of them, 10x the engineer they were before deploying AI. And so that's I like that. It's an enlightening thought. And I don't think it's unrealistic, as we are finding for our engineers, how we can get them more productive. And we're in very much a growing space as we're seeing such a high need for our chips. And so we simply need more productivity from our entire workforce. And that's something we're going to do together. And I think that the best way to do that together is to grow an ecosystem and collaborate together on those goals. With that, I'll end. Thanks so much.